Very good evening students and welcome to BYJU'S exam prep, the most comprehensive preparation app for all of the exam. I welcome you all to this session. Very good evening to all of you, and in this series of 99 percentiler in CAT for CAT 2024 students, we are revising number system concepts, and today's the concept is trailing zeros. Means the zeros which comes at the end of the calculation. So today we will be focusing on the concept of trailing zeros. I, Lalit Mandirata, welcome again to all of you to this session of number system concept of trailing zeros. We are preparing for upcoming CAT 2024 exam students. You all are welcome to BYJU'S exam prep. So let's begin with this session of trailing zeros. The zeros which comes at the end of the calculation. The very first question is let me tell you once again that the question which comes in the exam is related to the questions mainly of factorials, right? Means we will be finding the zeros at the end of factorial of a number. Factorial is a very bigger calculation. Means 25 factorial is students, product of 25 with its smaller numbers up till 1. Means 25, 24, 23, 22 up till 1. Okay. Now, the concept behind finding the number of zeros means actually we are finding how many tens will come in this whole product. How many times 10 will come in this whole product. Means you can see that 10 is formed when 5 is multiplied with any even number. Means 5 into 2 gives 10, right? So it means number of 2 and number of 5 will tell us number of tens in the product. Means one pair of 5 and 2 will make 110. If we have 3 5s and 3 2s, then there will be 3 tens. Okay. So it means number of 5 and number of 2s will tell the number of tens in the product. Okay. And we know that every second number is divisible by 2. So in product of or in factorial of any number, there will be more 2's than 5. You can see here 24 is having 2, 22 is having 2, then 20 will have 2, 18, 16, every second number is a multiple of 2, right? And every fifth number is a multiple of 5. So number of 5s are always less than number of 2's in a factorial of any number. Okay. So pairing of 2 and 5 will depend upon number of 5's, because number of 5 are lesser than number of 2's in factorial of any number. So actually the trailing zeros means we are concluding now what should be the concept behind finding the trailing zeros. Actually trailing zeros is number of tens in n factorial, right, which further equals to number of 5's in n factorial, right? Means how many times 5 will come in factorial of a number. That 5 will actually tell us that how many pairs will be formed for 5 and 2, and which will give us 10. So number of tens are dependent on number of 5. Now we know a method to calculate number of prime numbers in a factorial of number. Here we have 25 factorial. We need to catch how many 5's will be there. 5 is a prime number. So concept to calculate number of prime number or repetition of prime number in n factorial. The method is divide the number whose factorial we are having in the question by the prime number, right, and pick the quotient only after the division. So 25 and divided by 5 give quotient 5. Now divide this 5 again by 5, this quotient 5 again by 5, the next quotient will be 1. Now student, 1 is smaller than 5, we cannot divide 1 again by 5, so we will stop here and will add all the quotients. 5 plus 1 add up to 6. So number of 5's are 6. Number of 5s are 6, means highest power of 5 will be 6 in 25 factorial. So number of tens will be 6 again, and number of trailing zeros at the end of 25 factorial will be 6. So the concept is, to find the trailing zeros, we will be finding the number of 5s, right? And because number of 5 is always less than the number of 2s. So in the next question, student, the question is find the trailing zeros in 60 factorial. So we will find how many times 5 will come now. Simple, right? It's a question of just few seconds now, because we will be finding number of 5s. Pick the question. What will be the question? 12. Then 12 divided by 5. 5 to the 10. Only these two questions will tell us the number of 5s, which are 14. So trailing zeros will also be, trailing zeros in 60 factorial will be 14. So answer is A part, 14, right? A very simple concept now, because we understand how we conclude that why we are dividing it by 5, why we are finding the number of 5s. Okay, this is not factorial. Okay, we have a whole series, and in this series again what matters is number of 5s now. Okay, so we will be calculating number of 5s. 1 raised to power 1 will have no 5. 5 raised to power 5 will contain number of 5 will be 5. Number of 5s will be 5. Then we have 10 raised to power 10. 10 raised to power 10 is actually 5 into 2 raised to power 10. How many times 5 is coming? 10 times, right? 10 times. This is 5 times, so this is 10 times. 15 raised to power 15. 5 into 3 raised to power 15. How many times 5 is coming? 15 times. 20 raised to power 20 is 5 into 4 raised to power 20, right? How many times? 20 times. Now 25 is actually now 5 into 5 raised to power 25. Both the 5 will be occurring 25 times. So here we will double the number of 5. 25 first time and 25 second time. Total 50 times, right? And this all is going up to 50. This all is going up to 50. Means with a gap of 5, 5, 5, 5, we will move up to 50. So next number will be 30. 5 raised into 6 raised to power 30. So 30 times. Then 35. 5 into 7 raised to power 35. So 35 times. Then we have 40. 5 raised to power 40. Because this is 5 into 8 raised to power 40. So 40. Then 45. 5 into 9 raised to power 45. So 45 times. In 50, we will be having double of this, right? Because 50 is 25 into 2. And in 25, we have 5 and 5 both. 50 times, so total 100. Now we need to total this 100, then 45 and 40. Here we have 35, 30, 50. 35, 30, 50. Then we have 20, 15 and 15 again 30. So 30 and 20, 50 and 50, 100. Right? This is also 100, 200. Right? This is 200. This is 80, 280, 280 and 40. 320, 320 and 30 is 350. So answer is 350. I think this is miswritten. This is 350. Answer is C part, 350. Right? So total number of 5s here are 350. So number of trailing zeros will be 350. Find the number of zeros at the end of all this product. So we have a factorial again, but with the factorial we have some numbers also. So we will be finding the number of 5s in both. Means in 140 we will divide 140 by 5. 5 2 times 10, 5 8 times 40. 28. 5 into 5, 25. Then 5 divided by 5, 1. So total 34 times 5 will be here, right, in 140 factorial. But we have some other numbers also. First is 5 into 1. So number of 5 is 1 time, right, 5 raised to power 1. In 15 again we have 5 into 3. So again there is 1 5. In 22 we won't have any 5. In 11 there is no 5. In 44 there is no 5. But yes, 135 is product of 5. So if I divide this by 5, 5 into 2, 10, 5 into 7, right? So again we have one more time 5 here. So how many times total 5? 1, 1, 1, right? 1 plus 1 plus 1, 3 here and 34 here. Total is 34 plus 3, that is 37 times, because in product we add the number of powers, right? Means in this we have 5 raised to power 34, and in all this product we have 5 raised to power 3. So when bases are same, power gets added. Total number of 5s are 37, right? Number of trailing zeros in product of 2 factorials, right? So in 95, let's find how many 5s are there. 5, 1 time 5, remainder 4, 19. 5, 3 times 15, so quotient is 3. 3 is smaller than 5, so we'll stop here, right? 22 number of 5s are there in 95 factorial, and in 140 we have just calculated it is 34 in number, right? In 140 we know the number of 5s are 34 in number. So we are not calculating this again, because we know that the number of 5s are there is some technical error. Okay. In 140 we have 5 raised to power 34, right? So 34 here, and in this we have 5 raised to power 22, right? So 5 raised to power 22 and 5 raised to power 34, right? Again in product the power will get added. Again in product the power will get added. So we will add 22 to 34, right? 5 raised to power 56. So total number of 5s are 56. Total number of trailing zeros are also 56 in number. Next question. Here we have a whole product where we need to check again how many times 5 will come. Okay. Student, in every number we have 2, right? This is first 2 is 2 into 1, second 2 is 2 into 2, then 6 is 2 into 3, then 8 is 2 into 4, and this is 2 into 90. So we can see that 2 is there 90 times. Take this 2 out from every number. 2 into 1, 2, 2 into 2, 4, 6, 8 and 180, right? So 90 times 2 will come out. We will left with this all product, and this product is, students, 90 factorial, right? So in 2 raised to power 90 there is no 5. 90 times it is 2. So there is no 5 in this part. Leaving this, only the number of 5 will be in 90 factorial. So divide 90 by 5. 5 1 time 5, 8 times 40, right? 5 3 times 15, that's all, right? So 18 plus 3, total 21 number of 5s are there. So trailing zeros are 21. So number of 5s are 21, which means number of trailing zeros are also 21, because they are equal. Find the number of zeros at the end of the product of, again, the last question was the multiples of 2. Here we have multiples of 3. So I am taking 3 common, or all the 3's which are there in the product, separating those 3's out. So how many times? Last is 3 into 60. So 60 times 3 will come out, and we will get 1, 2, 3 up to 60. That means this is 3 raised to power 60 into 60 factorial. Right? In 60 factorial, student, 12 पंजे 60, 5 दूनी 10. We have 14 number of 5's. Right? So number of 5 tells us number of trailing zeros. Trailing zeros are 14. So answer is first option. So simple. Okay, here we have multiples of 5. So taking all 5's out means every number is multiple of 5, and how many times we have 5 till last number is 5 raised to power 36, right? So means that is 5 into 36. So 1 into 2 into 3 into 4 into 36. So this will become 36 factorial, and in 36 factorial, how many 5's are there? 5 7's are 35, then 5 1 time 5, total 8. Total 8 5's are there. So we have 5 raised to power 36 into 5 raised to power 8, right? 5 raised to power 36 into 5 raised to power 8. So we will add now these total number of 5's, means at last we have 8, also we have 36. So total number of 5's are 44 in number. So trailing zeros are also 44 in number. These answers are wrong, right? These answers are wrong. Answer is 5 raised to power 44. That's all with today's session of trailing zero, students, and I will see all of you now on the application of BYJU'S, where we will be revising and practicing this whole session in the form of a kind of rapid test, right? So after this session we will be starting at 4:45 the same topic, trailing zeros, but on the application of BYJU'S. Those who haven't downloaded the BYJU'S application until now, please download it, because we will be practicing now this topic, and we will be doing a kind of a practice session on this topic on the application today itself at 4:45. So that's all with today's session, student. See you all at 4:45 on the application of BYJU'S with the same topic. Take care. Have a nice day.